Okay, 2NA, today we are doing chapter 7.1, Simple Algebraic Fractions, textbook page 145. So you need to go to your textbook page 145 for this. Now, before we continue with this chapter, I want to do a very simple recap on our basic algebra. First, x squared is not x plus x. X squared is x times x. X cubed is not x plus x plus x. X cubed is x times x times x. Next, if I have x squared y, the square belongs to x and not the y. So x squared y means x times just one time of y, because y is a power of 1 here. If we have x squared y cubed, similarly, the power 2 belongs to the x and the power 3 belongs to the y. So x squared y cubed is actually x times x, 2, which is just 2 times. Multiplied by y cubed is y times y times y, 3 times of it. Alright, so this is the basic algebra recap that we need for this chapter. Before that, let's continue. Before we continue with work example 1, let's think about this. 2 plus 3 over 2 plus 7. Can I just simplify the fraction just by doing this? Let's try. If we just cancel out the 2, we get 3 over 7. In actual fact, 2 plus 3 is 5 and 2 plus 7 is 9. 5 over 9 is definitely not the same as 3 over 7. So you cannot do that when you have numbers adding up together. If it's 2 times 3 over 2 times 7, can I just cross out the 2 like this? Let's try. That would give me 3 over 7. Let's really go and multiply it. 2 times 3 gives you 6 and 2 times 7 gives you 14. And if I were to divide by 2 on the numerator and denominator, I get 3 over 7. If you realize, they are the same. If they are the same, I can cancel out if it's connected with a multiply. So if I have 3 over 9, a normal fraction like this, how do I simplify this fraction? All I just need to do is divide by the common factor, which is divide by 3, and I'll get 1 over 3. If you need time to absorb what I just said, you can pause the video now and think about this. I'm going to go into work example number 1 for simple algebraic fractions. Work example 1, part A. I'm going to write out full working, but in the exams, you don't have to write out the full working. We have 3xy cubed over 9x to the power of 4y squared. If you look at this carefully, the cube belongs to the y, the square belongs to the y, the power 4 belongs to the x. The x on the numerator has an invisible power 1. There's only one x there. So if I were to use the concept, it's actually 3x, y cubed is y times y times y. At the denominator is 9, x to the power of 4 means x times x times x times x, y times y. Now, it's time to start cancelling. Note that all these are connected with a multiply. And like what we discussed just now, if it's connected with a multiply, we can basically just cancel them out. Okay, so what can we cancel out? We can cancel out the x and the x. We can cancel out 1y below, another y below, another y on top. Okay, at the numbers here, I can divide by 3, I get 1 and I get 3. So my final answer is just 1y, which is just y, and on the denominator is 3, x times x times x is x cubed. And this is my final answer. What I'm doing is that I'm simplifying this algebraic fraction. That is work example 1a. Let's take a look at work example 1b. Work example 1b is a little bit more interesting because we have a bracket. So work example 1b is 28. X cubed is x times x times x. Now x plus y squared is actually x plus y multiplied by another x plus y. Let's take a look at the denominator. 63 xy squared is x times y times y. X plus y to the power of 4 is x plus y, x plus y, x plus y, x plus y 4 times, because it's to the power of 4. Let's look at the common factors that we can divide on top and below. If you notice, I have x that is the same, so I can cross out x. If you notice, x plus y, the entire group x plus y is the same, so I can cross out the entire x plus y. And I have another x plus y that I can cancel out. Now, let's go to the numbers. 28 and 63, what can I divide by? I can divide by 7, divide by 7. If I divide by 7, this will give me 4. If I divide by 7, this will give me 9. And my final answer would be, on the numerator is 4x times x is x squared. At the denominator is 9 y squared x plus y, the whole thing square. And that is my final answer. I cannot simplify it further. This is work example number 1. That's all for work example number 1. Look at the next video for work example number 2.